centimeters. Okay, so today we're going to talk, you guys know this already, but we're just going to do a quick little review. Please just make sure, I'll give you time to do questions, don't worry, you're not going to have homework today. But just listen here, of course. So it says here, scientific notation is often used to write very large and small numbers, which of course is Avogadro's number, for example, 6.02 times 10 to the 23. In scientific notation, numbers are expressed using the following form, so x times 10 to the n kind of thing. X is a number with only one non-zero digits, 1 to 9 basically, to the left of the decimal point, and n is a positive or negative exponent. You guys can write those in there. No, don't write anything else down. Just the typing part there. So x is a number basically from 1 to 9, okay, to the left of the decimal point. N is a positive or negative exponent. Positive exponents indicate that the number is larger than 1, okay, greater than 1. And a negative exponent indicates a number is less than 1. There's a couple of examples if you just want to write them down real quick, that probably wouldn't hurt. And then the value of the exponent indicates the number of times you have to move the decimal point. Positive 2, you're going to move it 2 to the right, and like I said, 2 to the negative 2 would be 2 to the left. Okay, so we're going to give a couple examples here. Let's see. I can't erase that now, I guess. Okay. Let's just do these on a separate sheet here then. Let's do that. I don't need this anyway. Let's just stop. Simple, what do we got here? Example 1, 53,000. Okay, we're going to write that in scientific notation. Remember, it always has to be a number between 1 and 10. So we're basically going to pick a number between 1 and 10 here in this case. A number between 1 and 10 would be 5.3. Yes? Would be a number between 1 and 10. We don't have to worry about the zeros because the times 10 part will take care of that. Yes? So we're going to go times 10 to the, if the decimal was here 5.3, 1, 2, 3, 4 to get it back to where it needs to be. Yes? So times 10 to the 4 in that case. Okay? Is that good? Yes? 150, I think, is your next number here. Again, always pick a number between 1 and 10. It can't be 10, by the way. So 1.5 would be acceptable in this case. Again, if the decimal was here, you'd move it 2 places to the right. So times 10 to the 2, times 100 basically is what that is. Okay? The next one here is 0.000, what is it, 563. Okay. In this case here, a number between 1 and 10, so 5.63 times 10 to the, we got to go to the left this time, 1, 2, 3, 4 places to the left, so negative 4. Okay. And lastly here we got what? 0.0435, and again, we'd want to pick a number between 1 and 10, 4.35 times 10 to the what? 1, 2. So negative 2 in this case because we're going 2 places to the left. Good? Okay. Questions, anyone? Good? Okay. What if you had to write it back in standard form? So standard form basically is just a number. So if we have to get it back to number examples here, everyone got that? You good? Kate, good? Yeah. Haley, good? Okay. If you guys need to write this back into regular, just standard form, 5.4 times 10 to the 2, okay? Again, times 10 to the 2 implies times 10 to 100 basically, so 100 times. Move the decimal 2 places over, so 554 would be your answer there, standard form. 524 times 10 to the negative 1 should be what? Let's see, is that right? Yeah. 0.3524. We're going to move it 1 place to the left, of course, because it's a negative 1. 5.67 times 10 to the 5. Again, in this case here, we're going to move it 5 places to the right. Okay, so 5, 6, 7, 0, 0. Let's see, 1, 2, 3, 4, 5. I guess I need one more there. Okay, something like that there. And then what do we got here? 2.9873 times 10 to the negative 3. And in that case there we have I'm going to move it 3 places to the left. So 0.00? I think so. 29873. Okay. Is that right? 1, 2, 3. Yeah. Okay. Like so. Good. Okay. The most important thing is this. Okay. And I know on the next page here we're actually gonna. I have actually a couple issues with the next page here, but remember, the most important thing is I want this number here. These numbers, if you notice, are all numbers between 1 and 10. Okay? They have to be between 1 and 10. So we need like 2.4, not 24.5. Okay? We don't want that. We want a number between 1 and 10. Okay? It has to be between 1 and 10. I'm going to give you a couple minutes here. I don't know what, 3 to do that? 5? I don't know. I'm going to let you guys work on the next part of this worksheet, or the bottom part there. Go ahead and write those numbers out there. I'll give you a little bit of time for that. So we've talked a little bit about significant digits before, but we'll talk about them again here, just a little bit of a reminder here. So it says, when reading a scientific instrument like a graduated cylinder or a ruler, the last digit recorded is estimated. Refer to the diagram on the right. The number of digits that the recorded value has indicates the degree of certainty of the measurement. The more digits, the more certain the measurement is. For example, if you're talking about 55 grams versus 55.000 grams, obviously one is more accurate or more precise. Okay. So basically, determining the number of significant digits. All non-zero digits are significant. How many digits are significant digits are in the following? So 159. How many significant digits do you have there? 3. Okay. What about 45.5, which is not scientific notation, by the way, times 10 to the negative 3? How many significant digits there? 3. And what about 214.65? 5. Okay. So any non-zero digit or any non-zero number is significant. Okay. 1 through 1, 2, 3, 4, 5, 6, 7, 8, 9. Zeros placed between the digits are significant. Okay. So for example, 4005. You'd have how many here? 4. Okay. What's the next one there? 909, of course, would be 3, and 45.009 would be 5. Okay. So 4, 3, and 5 there. Good. Okay. Zeros placed after digits are significant. So there are some variations to this rule, but this is the way basically diplomas in Alberta, that's the way we do it here. Okay. So for example, how many significant digits are in each of the following? If we have the number 2.300, how many do we have there? 4. Okay. So the zeros at the end count. Zeros at the end count basically. 4,500 would be 4. Okay, and then 3.0600 times 10 to the 3 would be how many there? How many? 5. Okay. I think that's, yeah, 5. Okay, good. 5. Okay, good. Zeros placed before the numbers do not count. Okay. So this is kind of the only time that they kind of don't count, and that's, for example, 0.00067, I think it is. How many significant digits do we have there? 2. Okay, so only the 67 counts. 0.0506 would be what? 3? Yes. Okay, and then the .0048. Oh, come on. 8, 900 would be, how many would you have there? 5, yes? Okay, the zeros in the front don't count, and the zeros at the end do. Okay? All right. Yeah, so then, and then again, exact numbers are defined or counted values are considered to have an infinite number of significant digits. So, for example, we talked about 3 eggs or 2 people or Avogadro's constant or others like any kind of constants we have, we kind of ignore those as far as significant digits, okay? In this unit, we're going to talk about acceleration, for example, which is acceleration due to gravity, which is 9.81 meters per second squared. That's not going to ever come into a factor as far as significant digits goes, okay? All right, here we go. A calculated answer with significant digits, am I recording? Yeah, okay. Cannot be more certain than the measurement that it's based on. The final answer needs to be rounded so that it contains the same number of digits. So we kind of did that in, if you remember, chemistry, which was a little while ago. But 1678.23 rounded to two digits would be this number here. So 1678.23. If I had to use, let's say, 2 significant digits, I'd have to, of course, do some rounding and, of course, scientific notation. There's no other way to record this answer. I mean, right now, how many significant digits is this right now? 6, right? So I need to get 2, so I'm going to have to do that, okay? And again, I'm going to have to round. Basically, there's my 2 right there, right? I mean, it wouldn't make sense to pick any of the other 2. I'm going to have to round this because that's that there. Let's see, I go 1, 2, 3 places to the left, yes? So that's what I want to put in that little blank there for that one, okay? Now, if you're multiplying or dividing, it goes based on the fewest significant digits, okay? Fewest significant digits. So, for example, okay, 1.52 times 0.85. 1.52 times 0.85. And you know what? I'm just going to grab, I don't know. No, I guess I'll just grab this one because I don't know where my other calculator is. But if I'm multiplying, I go based on the fewest significant digits, yes? So what did I say here? Let's get rid of this thing here. There we go. 1.52 times 0.85 would be what? 1.292. By the way, that would be meters squared. Also in this unit, it's going to be very important to use units, as always. And we need to do what here? Okay, we're going to look at these numbers here. So how many significant digits do I have here? 1.52 is 3, and this is how many here? 2. So I can only have 2 in my answer, basically, is what they're saying. I have to go with the fewest significant digits. So since I only have 2, I can only have 2 here, which would be, 1.3 would be my final answer here. And then, of course, we're going to circle it, etc., etc. Okay? Or underline it or whatever. Okay? Good? Next. Wow. There's a song about that from, I think it's the Beastie Boys. 4.798 times 10 to the 2, and we're going to divide that by 2 times 10 to the 3. All right? And then, of course, we have 3.5 times pi here as well. And when we go to do the first one, I'll do this on the calculator, but just remember there's a couple ways you can enter this. Make sure you use brackets, yes, or use the E function, yeah? So this is going to come up again this year here, or this unit, I should say. 4.798. Like I said, maybe it's better if you use the E to the 2, divided by 2, doesn't really matter about the decimals there, 2E3. Okay, we should get about 0.2399. And again, significant digits, and I don't think there's any units with that one. Significant digits, how many significant digits should I have in my answer in this case? 3, right? So that's 3, that's 4, so let's have 3. So I'm going to have to go to 2.240, yes? Remember the 0 at the end counts, yes? Okay. So instead of 2399, I'm going to have to go to 240. Okay, 0.240. And then this one here is 3.5 times pi. Let's see, where's pi? there. And again, pi is infinite number. Okay, it's a constant kind of thing. So we have 10.9955. And in this case here, we should only probably have what? 2 significant digits, yes? The 3.5 part. So 2 here would have to go to 11 probably, I guess. Good? Okay, questions anyone? Yes, no? Alright. Is this going to work? Alright. Now, if you add or subtract, it's a little different. Okay? Adding or subtracting goes based on decimal places. Okay? Decimal places. So, for example, 60.65 kilograms. And on that, we're going to add 50.2 kilograms. Okay? Now, first thing you're going to do is you're going to add these together, obviously on a calculator or whatever. So that should be 110.85. Is that right? Somebody? Okay. Now, we have to go based on decimal places, and that's where this changes here. This is 2 decimal places right here. Okay. So forget about significant digits. It's based on 2 decimal places. So this person has a ruler that's pretty accurate. It can do, or sorry, I guess this is a kilogram thing here. So maybe a weigh scale. Okay. So a weigh scale is pretty accurate. It's got 2 decimal places. It says 6.5 on it. This one is only 1 accurate to 1 decimal place. And because that guy's only accurate to 1 decimal place, that's what we need to record in our answer. Okay. So in this case here, I'd say 110.9 kilograms. 1 decimal place, 1 decimal place. Okay. That's if you're adding or subtracting. Okay. Does that make sense? Basically, what we're saying is this guy's scale here is not very accurate, or not as accurate or precise as the other one. So therefore, we can't be sure of what that next number would be. So I can't be sure in my final answer what the next number would be. Okay, that's basically how that works. Okay, what's the next one? 12.3 minus 0.12, which should be 12.18, I believe. And again, 1 decimal place, 2 decimal places. 1 decimal place, 2 decimal places. So 1 decimal place in my final answer here. Okay. And last one here is 4.890 and 10, which of course, again, we're going to add those 2 together. We're going to get 14.890, and we got 3 decimal places there. 3 decimal places. This has no decimal places, right? Basically just 10. Okay, whole number. So again, I cannot have any decimal places in my answer. I have to round it to 15. No decimal places. Okay, good. So that's what you're looking at there. Okay. Last few here. If we are doing a multi-step problem, so let's say there's some multiplication, division, addition, subtraction, basically. It says do not round until the very end. If you have multiplication or division and addition, subtraction are both used, we use the multiplication division rule. So we go back to how many significant digits do we have in the question, basically. Okay. So if we had something like this here, 5.3 times, what is it, 76.8 plus 1.010, okay? I would probably enter that in the old calculator. So what was it again here? 5.3 times 76.8. And I'm going to add on to that 1.010. And I get 408.05 as an answer. Okay, good. And now we go back and look at significant digits now. Okay, so again, we have 2 here, 3 here, and we technically, I guess, have 4 here as far as significant digits goes. Okay, so we basically just look at, you know, I mean, if we still consider that to be 4 in this case because we're going to use the multiplication addition rules. I can only have 2, so I'm going to have to go to this number here. So pretend the decimal's here, 1, 2 places to the right. Okay? 4.1. 2 significant digits, so those are the 2 that I'm going to look at then. Yes? Okay? Good. Questions, anyone, on any of those? Sure? Okay. I'm going to give you some time to work on those questions, or the first ones, and if you're not done those, you can finish those up. And that's pretty much, I think, probably it for the day today.